Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about rational exponents. Thanks for checking out my channel. Hope you enjoy it. If you do, please leave a comment, give me a thumbs up, and I'd love it if you would subscribe to my channel. Let's get going. Rational exponents. Let's let a, b be integers. So a and b are integers, and b is bigger than or equal to 2. So we're going to define this radical here. So this is the bth root of a to the x. We're going to define this as follows. It can either be x raised to the rational exponent of a divided by b, or we can rewrite it because of exponent rules. We can rewrite it as a to the x all raised to the power of 1 over b. Or we can rewrite it as a x to the 1 over b, all raised to the power of a. So you might wonder, why so many different options? Well, our rules just open up the ability for us to choose which of these circumstances we like the best. And when I say we like the best, meaning which is the easiest for a specific situation. Oftentimes, when you're dealing with radicals, like this bth root of x to the a, you'll need to simplify them. And when you simplify them, let me give you an example of what I mean. We have 27, for example, raised to the 2/3 power. We have two options. We can do 27 squared first. What is 27 squared? 27. I don't know what that is. Let's look it up. 27 squared is 729. 729. And then find the cubed root of 729. I don't know what that is. Do you guys know what the cubed root of 729 is off the top of your head? If you do, put it in the comments because I'd love to know. I don't know what that is. I'd have to get a calculator. But my point is, this isn't super, you can't do this by hand. Most of us can't do this by hand, right? So if we chose to square it first, which back up here, so this option is right here. It's the square first, or the exponent first, and then the root second. So first square or exponent, second root. That's not a super great option for us. If we tried it the other way, meaning if we took the root first, what is the cubed root of 27? That's much easier, right? 3. 3 times 3 is 9, times 3 is 27. So this is 3. And what's 3 squared? And then we take the square second. 3 squared is 9. That's much easier. We can do that in our heads. So actually that tells us, what's this one right here? That must be 9. So the cubed root of 729 has got to be 9. Those of you who wrote that in the comments, I hope you got it right. So it's really important here. We can use these rules to our benefit. So to review, we can rewrite, let me use this example here, the cubed root of x squared. If we rewrite it as a rational exponent, rational means a fraction, so a fractional exponent, we can rewrite a radical as a fractional exponent. The power goes in the numerator. The index of the radical goes in the denominator. And then once that happens, we can choose one of two options. We could take the power first and the exponent second. Sorry, the power first or the radical second. Or we could take the radical first and the exponent second. Just depends whichever is easiest for our specific situation. Now I have one last note down here at the bottom. If we have a negative exponent, what that means is that I have to take the reciprocal of the base. So let me give you a quick example. So if we have 2 to the negative 3, the base here is the 2. So when I take the reciprocal of the base, I flip it. So that gives me 1 over 2. And then my negative in the exponent is now gone. And then I apply my exponent rules and have 1 to the third power over 2 to the third power. 1 to any power is just 1, so that just gives us 1 over 2 to the third. So it looks like we just did 2 to the negative 3. That equals 1 over 2 to the 3. So it looks like we just took the 2 to the 3 to the bottom, and the negative went away. That's the end result. That's what I'm showing you here in this rule that I just boxed out in pink. X to the negative a over b equals 1 over x to the positive a over b. And here's a quick example. If I have x to the negative 2/3, that just comes down as x to the positive 2/3. And this whole thing right here is what's happening. I'm flipping the base, or I'm taking the reciprocal of the base, and then applying the exponents to both the numerator and the denominator, but I'm skipping those 2 steps here in this example. I just go straight to from the start to the end, which is probably what you will do once you get the hang of it. And if I wanted to go back to radical form, I could put the cube root of x squared if I wanted, but either way is fine. This is actually a super, super helpful rule. I think once you have mastered it, you'll start using it all the time. Let's do some examples. First example, 81 to the negative 3/4. Well, first, let's deal with the negative. So that means this comes down, so 1 divided by 81 to the 3/4. Now, the exponent is positive. That's good, because exponents always need to be positive if they're simplified. And we've got 2 options. We can take 81 to the third power first, and then take the 4th root, which again is not what I want to do, because I don't know what 81 to the third power is. If any of you can do that in your head quickly, put that in the comments. I'd love to see. I can't, but the 4th root of 81, I could probably do that, because 81 is 9 times 9, and both of those have 3's, so that's 4 3's. So I bet the 4th root of 81 is 3. So we have 1 over, let's do the 4th root of 81 first, and then we will cube it second. So that gives me 1 over 3, because that's what the 4th root of 81 is, cubed. 3 cubed is 27. And we're done. So you can see we use that rule to make our problem easier for us. I mean, of course, we could have done it both ways. I just would have needed a calculator, and maybe you would have too, but we could use the rule to help us do it in our head without having to use a calculator. This next one, we are multiplying 2 things together. Let's use the rule of, let me erase that and start again. Let's use one of our rules of multiplication, which is the commutative rule, meaning we can rearrange the order of a bunch of things multiplied together. So let's put all the numbers together. So 5 times 7, and we have x to the 1/2 times x to the 3/4. So the 5 and the 7 give us 35. And the x, we add the powers. So we have 1/2 plus 3/4, because we have x to a power times x to a different power, the same base. We add the exponents. What is 1/2 plus 3/4? Well, let's see. We need 2 over 2 here to get a common denominator of 4. So that gives us 2 over 4. Let me make that a little bit better. That's kind of a terrible 4. 2 over 4 plus 3 over 4 gives us 5 over 4. So this gives us 35x to the 5 over 4. And we're done. Let's do C. We can look at this right away and be like, hey, 32, let me change that color. It's kind of hard to see. 32 and 16, that gives me 1 and 2. That's really helpful, right? And then after that, we can say we've got 2 times x to the 5/3 all over x to the 3/4. Well, let's split this up. We have 2 times, and then we have the x's. 5/3 and x to the 3/4. Our exponent rule says that when we have x to the something divided by x to the something, we subtract the somethings or the exponents. So this gives us 2 times x to the 5/2, or 5/3, sorry, minus 3/4. Does your OCD scream at you when I just did that? How about we make both those fractions with the same fraction where? So 5/3 minus 3/4. What is 5/3 minus 3/4? I don't know. Let's figure it out. We need to get a common denominator. So we have 5/3 minus 3/4. The smallest thing that both 3 and 4 go into is 12. So this needs a 4 over 4. This needs a 3 over 3. What does that give us? 20 over 3 minus 9. Whoops, 20 over 12, I should say. Minus 9 over 12 gives us 11 over 12. Okay. So we get 2x to the 11 over 12. And we're done. Not too hard. These rules really help us. If you ever get stuck when you're doing a problem, you should really go back to the rules. Go to whatever section you're working. If you're in a class, go to the book where the section you're working in, look at all of the rules and say, which one of these rules can I apply? Because those are really your tools. That's really how you do anything. Let's do D right here. Let's rewrite this, shall we? I want green. Let's rewrite this as x. Remember, the power goes into the top. So 2, and the index on the radical goes in the bottom, over 4. So we're simplifying all of these, right? So I'm going to come down below. X to the 2/4 is really the same thing as x to the 1/2. So we could really write that as 1 in the power. So we've got x to the 1 power, or we could just erase that and just do x. And 2 is the index on the radical, and that's the square root. So we just rewrote the 4th root of x squared as the square root of x. Exact same thing. Kind of cool, huh? All right, to the last one. This might kind of close the loop for some of you. Some of you might have been wondering, when you look at this, you probably think it's just going to be x, right? Because I've been told all my life that these just cancel and pop. Out comes x and we're done. But really, why is it? Why does that happen? Well, let's rewrite this radical in exponential form. And we get x to the, in the top, we have 3. In the bottom, we get the index, which is 3. And look at that. X to the 3 over 3 is just 1. X to the 1 is just x. That is why x comes out of the radical. Because 3 over 3 is 1. Because the exponent and the exponent is here, and the index of the radical, they make a fraction when we rewrite it, and that fraction becomes a 1 and goes away in the exponent. So we're just left with the base. We're just left with the x. Kind of cool, huh? Now, you know. Kind of makes me think of G.I. Joe. Knowing's half the battle. Okay, I just totally dated myself. Hope you enjoyed it. Let me know if you did, and if you're a G.I. Joe fan in the comments. And have a great day.